New Horizons flew past the Pluto-Charon system on the 14th of July last year. The data are still coming back to Earth because there's such a weak signal. The data rate has to be pretty slow. Pluto and Charon are a double object, and they have both turned out to be very complex bodies when you look at their geologies and you look at the atmosphere of Pluto. Charon doesn't have an atmosphere. And they are both orbited by 4 more tiny moons. We now know the size and shapes of these other moons. They're quite elongated bodies. They're quite heavily cratered, as much as you can see on the data. So they're old surfaces. The two that have been seen at highest resolution, you can see enough craters on their surface to say that surface has been around a long time. So it probably goes back 4 billion years.
Now, as New Horizons went past Pluto and Charon, it gave us unprecedented opportunities to look at both the atmosphere and the surface of both of these bodies. So first of all, what did the atmospheric measurements reveal?
Well, by looking at the sun disappearing over the limb of the two bodies as we flew by, we could see the sunlight dimming, and we confirmed that there's absolutely no trace of an atmosphere on Charon, but Pluto's atmosphere is extremely complex. It's a nitrogen-rich atmosphere, as indeed is the Earth's atmosphere and Titan's atmosphere, big moon of Saturn. But there is methane there, and high in the atmosphere, where sunlight gets to work on it, the sunlight is stripping hydrogen molecules, or hydrogen atoms rather, away from the methane, making free radicals which can stick together and grow into these chains of hydrocarbons. And some of this gunk settles to the surface.
Right, so we're having sort of hydrocarbon snow happening here.
Yes, probably not snowflake sizes, but just tiny little particles settling down. But where it's collected on the surface, it's very patchy. And this is one of the things we don't understand, the patchy nature of the dark material that's collected on the surface.
What about the surface analysis? Because these were the most detailed, the most high-resolution close-up pictures we've ever got of this system. So what do the pictures reveal of the surface and the geology of Pluto?
Well, they're absolutely amazing. We really only saw in detail one half of each body, but what we saw is mind-boggling. I'm a geologist, and I just love the geology we see. Faulted valleys with down-drop floors. We see mountainous blocks on Pluto where the water ice crust has been broken apart and blocks have tipped over. You have to remember that out at Pluto it is so cold that water ice, which is what forms the surface of both Pluto and Charon, is strong and rigid, just like rock on the Earth. And it's the other ices that are mobile and will behave like glaciers. And in fact, there are glaciers of nitrogen-rich ice flowing out of the mountains on Pluto, where they're possibly fed by nitrogen snowfall from the atmosphere.
What's driving this, though? Because it's so far away from the sun, the energy out there must be really low. Is it just the same sort of process you have on Earth, but with colder things that are liquids at lower temperatures like nitrogen, but it just takes a lot longer because there's less energy?
It certainly helps to have things which are mobile at colder temperatures. Even so, the heat source is a bit of a problem. It could be radiogenic heat generated by decay of radioactive elements. Now, there is rock inside Pluto and Charon, so there'll be some uranium, some thorium, some potassium, and there may be some potassium salts dissolved in the ice as well. So some radioactive heat, but maybe not enough. And if you look at the other icy bodies in the solar system, moons of Jupiter and Saturn, it's tidal heating which does it. But they're orbiting a large planet with a lot of gravitational potential to distort the shape of a body, which is what you need to generate tidal heat. And you don't have that option in the Pluto-Charon system. So it is a controversy about what's powering it. Now, one way out is to say it's heat left over from the collision which created the Pluto-Charon double system. But there wouldn't be much heat left over from that if it did happen 4 or 4.5 billion years ago. So I personally am left wondering, well, was this collision more recent? Was it only 1 or 2 billion years ago? And then there's residual heat from that you can call on today. So I think there are still mysteries out there awaiting resolution.
David Rothery taking me through the results from New Horizons, which came out this week in the journal Science.